Hello everyone, welcome back to our series of lecture for the course Probability and Statistics. So in today's lecture, we are going to solve some exercise problem, right, related to this random variable. Okay, so just look at the first problem. A deck of 10 cards numbered 1 through 10 is shuffled, right? So a deck of 10 cards we have, and which are shuffled, and each card have some number between 1 to 10. So 10 cards, 10 number. Now 5 cards are randomly selected without replacement. So among this deck of 10 cards, you selected 5 cards, and it is randomly you have selected. Now if y is the smallest numbered card among the selected card, then y is a random variable. Then the first question is, so that what values y can take. So what is y? Y is the smallest numbered card among this 5 card, which you have selected randomly from a like from the 5 cards from the deck of 10 cards, right? So y is the smallest numbered card. Then what value y can take? See, so this 5 card can have can take the value 1, the number card number 1. So y can have the value. So number A answer is y can have the value number 1, the smallest number, and then the if y is 1, that means the smallest number is 1, and then the other 4 numbers are your maybe 2, 3, 4, 5, 20, other 10. No issue, right? Y can take the value 2 also. So 2 is the smallest card among this selected card, 5 selected card. Then the other card might be 3, 4, 5, 6, 7 up to 10. In this way, how much value y can take? Y can take the value 3, 4. Y can take the value 5 also. So the other 4 card can be like 6 to 10. One more thing, y can take the value 6 as well, because from 6 to 10 you can still have 5 cards. So all the last 5 card you can have. In that case, y can take the value up to 6, right? So these are the value y can take. Therefore, the random variable y will have these values. I hope you understand. So the last case is that you have taken the smallest number is 6, and the other 4 numbers are what? 7, 8, 9, and 10. So 5 can still possible while taking the 6 as a minimum number. Fine. So y will take these values. Okay, so first part is done. Now think about second part of this question. Find the probability mass function. So we'll find its answer. Before that, let us think some particular case first. Suppose you calculate the probability of y is equal to maybe 3. What does it mean? What does it mean? That you have randomly selected 5 cards, right? Among these 5 cards, the minimum card is smallest card is 3. So how many ways you can do this? It is now if the smallest card is 3, then the other 4 card can be which number? It can be number 4, 5, 6 to 10, any number. How many such numbers are there? Smallest card is 3 means the other 4 number can be one of the like 4, 5, 6, 7, 8, 9, 10. 7. Other 7 places it can possible. Right? So it is basically 7. And then out of this 7 card, 4 to 10, you have to get 4 cards. How many ways you can do? 7C 4 ways. And divided by total number of possible cases. What is the total number of possible cases? It is you have selected 5 cards randomly from a deck of 10 cards. How many ways you can do? 10C5. So P of y equal to 3 is 7C4 by 10C5. Clear? At the same way, Can you think of it? What is P of y equal to maybe 5? It means that the smallest cut is 5 out of the 5 randomly selected cut, and therefore the other 4 cut can be the bigger number from 5. So they can be the number from 6, 7, 8, 9, 10. So 5 cuts number we have to get the 4 uh, different cut number. So how many ways it is possible? The other 4 number can be the number between, so the smallest card is 5. So the other 4 cards are what? They can be number 6, number 7, number 8, number 9, and number 10. Right? So how many such things are there? 5 possibilities. How many cards you will have? 4 cards. So how many ways you can do? 5 C4 divided by the total number of possibilities. The 5 card you have to select among 10 cards. 5, 10 C5. Right? Now you should get this concept for generalized case. Find the probability mass function of y. So whenever y equal to 3, it is 7c4 by 10c5. Whenever y equal to 5, it is 5c4 by 10c5. So what is the probability mass function? So therefore, P of y is equal to k is what? So the smallest number is k, and the other 4 balls should be k plus 1, k plus 2, and it can take up to the value 10. How many ways it is possible? How many such things are there? It is 10 minus k c4 divided by 10 c5, right? Where k is equal to, what are the value? 1, 2, 3, 4, maybe 5 and 6. So this should be our probability mass function, right? I hope it is clear to all of you. So this is our probability mass function for this random variable. Right? Easy question, just you think of it. Okay, let me move to the next question. A fruit vendor has 7 baskets of apples ready for sale. So the fruit vendor has 7 baskets, and the number of bruised apple in each basket is as follows: 1, 2, 3, 4, 5. So the first basket will have 1 bruised apple. That means what? That the apple is smashed, or some way it is getting some, like it is a smashed apple, right? It got some problem. So the first basket will have only 1 bruised apple. Second basket have 3 bruised apple. Third basket 0. Fourth basket 2. In this way, seventh basket have 0 number of bruised apple. Now, one of this basket is randomly selected for a customer's order. So among these 7, one is randomly selected for a customer order. Then let y be the number of bruised apple in the selected basket. So y is the number of bruised apple in the selected basket. Then find the probability mass function of y. So the thing is that in this way, y is actually a random variable, right? And then what random variable can take the values? What is y? Y is the number of bruised apple from the selected basket. So that y can be any number, na? Because whenever you are selecting the first basket, then your y is 1. You are selecting the second basket, your y is 3. You are selecting the third basket, your y is 0. Fourth basket, your y is 2. Fifth basket, y is 1. So therefore, y can take which values? Y can take the values. It can be, if you have selected the third basket or the seventh basket, your y will be 0, no bruised apple. So y can take the value 0. If you have selected the first one and the fifth one, your y will be 1. In this way, y can take the value 0, 1, 2, 3, and 4. All the values y can take. Clear? Depending on which basket you are selecting. Right? Now find the probability mass function of y. Now how to find the probability mass function? You look at it. You have P of y is equal to maybe the number k, small k. suppose. What is this probability? So it depends on k which value is there we can find. So it is actually some this kind of number. If your k value is 0, that means if you have zero number of boost apples, what is the probability of that? That means what? You have to select the which basket. So if you zero number of boost apple is possible in this basket and third and seventh basket. So there are two such baskets are there where you don't have any boost apple. So what is the probability of getting these two basket? Two such things are there out of 7. So probability is 2 by 7. Just a minute. So it is 2 by 7 if k equal to 0. Similarly, what is k equal to 1? Probability of y equal to 1. That means probability of one bruised apple is possible. So if you are selecting the first one and the fifth one, if you are selecting the first one and the fifth one, so again the probability is 2 by 7 because there are two such baskets which contain only one number of bruised apple, right? Similarly, a equal to 2 is what? You have only one such basket, so it is, you have only one fourth basket, so it is 1 by 7. Similarly, k equal to 3 is what? So you have again one such basket, which is again 1 by 7. And k equal to 4 is what? You have one such basket, so again it is 1 by 7. So this would be the probability mass function. And for all other k, it is 0. I hope it is clear. Okay, let me move to the next example. Now, determining whether the following function can be defined as a probability mass function and justify your answer. So we have some function given with some values and we have to identify whether they can serve as a probability mass function or not of some random variable. See, a function fx is a valid probability mass function if it satisfies the two condition, right? One of our theorem we have learned. So we have, if we have fx, this value should be greater than or equal to 0 for all x, and summation of fx should be 1, these two conditions. Now look at the first one. Look at the first function given. Gy equal to 1 by 5 for y equal to 1, 2, 3, 4, 5. So gy equal to 1 by 5 for y equal to 1, 2, 3, 4, and 5. So first of all, gy is greater than or equal to 0. We can see the first condition is satisfied. So we have to see the second condition, right? So g of I, we have to get its summation value where I is equal to 1 to 5. See, that means it is g of 1 plus g of 2 plus g of 3 plus g of 4, and last one is g of 5. So how many such things are there? And now look at that, g of 1 is 1 by 5 because it does not depends on y, right? So all the values are 1 by 5, 1 by 5 like this. So 1 by 5 plus 1 by 5. So how 5 such 1 by 5 is there? So the value is 1. And therefore, this GOI satisfying both the conditions of probability mass function. So therefore, GY is a valid probability mass function, right? So GY is a valid probability mass function. Valid PMF. So the first problem is done. Now look at the second one. So how to do the second one? The same way. So HZ equal to Z by 15, where Z runs from 1 to 6. So let us see. So number 2 is HZ is equal to, what is that? Z by 15, where Z is equal to 1, 2, 3 up to 6. Now the first condition is, uh, okay, let us put the value. Z of 1 is 1 by 15. Z of 2 is 2 by 15, like that. So the first condition, that Hz is must be greater than or equal to 0. So first condition is satisfied. We have to look into the second condition. So the summation should be 1. So h of I is equal to what? I is equal to 1 to 6 hi. That means h1 plus h2 plus h3 plus h of 4 plus h of 5 plus h of 6. And this is basically h of 1 is what? 1 by 15 plus 2 by 15 plus 3 by 15, 4 by 15, 5 by 15 and 6 by 15. Now what is the total value? So all the denominators are 15. So numerator is summation of 1 to 6. It is into n plus 1 by 2. Therefore, is it not 21? Okay. 6 plus 3, 11. 4, 15, 18, 21. Okay. So it is 21 divided by 15, and which is not equal to 1. So the second condition of probability mass function is not satisfying. Therefore, Hz valid is not a valid probability mass function. Done. So at the same way, can't you do the part 4 and part 5th, like third post question and fourth question, the same way one can do, right? Just check the first condition is satisfying or not, and then if the first one is satisfying, check the second condition. If they are done, you can easily declare that whether it is a valid PMF or not, right? So I'm not going to do the C and D part. I hope you can do. So let us move to the next question. Given that fx is equal to c by 3 to the power of x, it is a probability mass function for a random variable that can take on the values x equal to 0, 1, 2. Find the value of c. So how can you do this? Again, that fx is equal to c by 3 to the power x. It is a probability mass function. Then it should satisfy both the conditions of the probability mass function, the properties. So we can use the second property to get the value of c, because we know that summation of fx is equal to 1. Now summation of fx means what? F of 0 plus f of 1 plus f of 2 must be 1. Now what is f of 0? It is c by 3 to the power 0. F of 1 is what? F of 0 is c by 3 to the power 0. F of 1 is c by 3. And f of 2 is c by 3 square. That should be 1. Now you just simplify it. You'll get c into 1 plus 1 by 3 plus 1 by 9 is equal to 1. And this will gives you the c into denominator is 9. So 9 plus 3 plus 1 is equal to 1. And therefore c into 13 by 9 is equal to 1. And which gives the value of c is equal to 9 by 13. Right? So we can easily calculate the value of c if it is a probability mass function. So we have taken the second property, and if the second property satisfy means their sum should be 1, and you can get this answer. Right? I hope it is clear. Now let me move to the next problem. It is of similar type. So given that g y equal to k by y plus 1 is the probability mass function, and where y can take the value 0, 1, 2 and 3. Find the value of k. The same kind of questions, right? So I hope you can do. Just for a hint, I think the final answer of this question may be k equal to, it will be 12 by, it is 25. 12 by 25. This may be the answer. Just you can check whether you are getting this 12 by 25 or some different answer. Right? Okay. So in the next video, we'll come up with some more exercise problem. Thank you very much.